everyone. Today we are going to solve a question that appeared in Shift 2 on April 6, 2023. The question says that the equilibrium composition for the reaction PCl3 added to Cl2 at equilibrium produces the compound PCl5 at a temperature of 298 Kelvin is given below. The concentration of PCl3 at equilibrium is 0.2 mole per liter. For chlorine gas, the concentration is 0.1 molar per liter, and for PCl5, the equilibrium concentration is 0.4 mole per liter. If 0.2 mole of chlorine is added at the same temperature, the equilibrium concentration of PCl5 is dash into multiplied by 10 to the power negative 2 mole per liter. We have the given value for Kc, that is equilibrium constant, for the reaction at 298 Kelvin is 20. So in order to start the solution, we need to first write down the chemical reaction that is provided in the question. As per the reaction, PCl3 is combining with chlorine at equilibrium to produce PCl5. Now the given concentration at T equals to 0 for PCl3 is 0.2 molar. For Cl2 it becomes 0.1 added to 0.2 as it is mentioned in the question. For PCl5 the concentration is 0.4 molar. Now when we see the concentration at equilibrium, for the reactants X amount will be dissociated, and for the product X amount will be formed. So it becomes 0.4 added to X. So now in order to solve the value of X, we need to write the expression for K equilibrium. So Kc in this case becomes equal to the concentration of PCl5 dividing it by the product of concentration of PCl3 and chlorine gas respectively. So if we substitute the values over here, in this case, we have the value of Kc provided in the question as 20. So 20 becomes equal to the concentration of PCl5, which is 0.4 added to X, dividing it by the product of 0.2 minus X, multiplying it by 0.3 minus X. Now if we solve for X, the simplified value for X comes out to be equal to 0.086. Now we need to find out the concentration of PCl5. As from the expression above, the equilibrium concentration of PCl5 is equal to 0.4 plus X. If we substitute the value of X in this case, we get the answer as 0.486 molar. The final answer to this question is 0.486 multiplied by 10 to the power negative 2. So we can rewrite it as 48.6 multiplied by 10 to the power minus 2 molar. So this is the final answer to our question.